Okay, number 12. We'll do 12, 13, and 14 in this video. Identifying the translations of the parent function, f of x equals x squared. Okay, so that's Big Mama that give this. All right, so this is kind of a redundant question like this. They all follow the same basic principles. The shifts happen when you have, if this was parentheses or an absolute value, the same transformation would have taken place. So here we have x minus 5 on that minus 5 on the inside means that we will be moving to the right 5, and a negative 4 on the outside of these parentheses means that we'll be going down 4. So right 5, down 4, right 5, down 4 is D. Alright? So that's a basic question. Now here, it was a mixed bag. So piecewise functions. Let's see. I kept the pieces were pretty basic. It's a quadratic, so we have Big Mama herself is right here, but she's only going to be graphed between on this interval. Then we have a line graphed on this interval, and then the constant 2 will be graphed on this interval. So I can see that the breaks happen at -2, -1, 0, and 4. Those are the key places. So I'm going to go ahead and just put dots here. -2, -1, 0, and 4. Okay, now I'm going to erase those. I drew them relatively faint here. Alright, now she is just going to be drawn between those two. So she's going to be drawn between here. Now she would normally go from here, over 1, up 1, over 2, 1, 2, 3, 4, up 4. Now I have very lightly these points here, but I only want this piece right here, from -2 to -1. And it looks like I'm going to fill it in here, -2, here, alright, and then I'm going to go down to here, but that's going to be open because there is no bar. Alright. Okay, now she should have went to here, but we are cut off. Then we take it up here so that we have a line with a slope of -1 and a y-intercept of 2. So positive 2 has a slope of -1, so this guy's going to go down like this. Okay. But we only want this part right here from -1 to 0. Okay. Now we don't have a bar, so we will put an open circle. Go right there. At 0 there is a bar, so we will fill it in. Okay. Now the rest of it is basically hidden. And now we just have a constant of 2. And the constant of 2 means that I will go to 2, and I'm going all the way to 4, and it is literally just a flat line. Alright, and there's nothing else to do. We don't know what those functions represent or why they represent what they do, but it's fine. That's how we graph a piecewise defined function. Okay, so that's 13. Now 14 looks like we've got -2 going from -3 to 0. So -2 from -3 to 0. Okay, so -2, there's no variable, so it's just a constant. Doesn't matter what you put into it, your output will still stay -2. But we do have a bar here, so we will define it here. But as we move across, we'll go all the way up to 0, but we won't include them. Here we have an absolute value. Now you guys actually were super close to getting this right, a lot of you, but this is an absolute value that doesn't go from the origin like this. Okay, this guy moved to the right too, so he's here. Okay, and he's a V that goes this way, and a V that the V shape will go this way. But we only want it from 0 to 2, so there's no point. We'll close it up there. Okay, we're going to go right here and stop. Now he should go this direction, but it looks like we only go up to 2 anyway. So now I grab another line, I go up to 5, 2, 3, 4, 5, and this guy goes down 1 over 1, down 1 over 1, down 1 over 1, Okay, and there he is, faint. Okay, now I have a pen or else I'd erase it. But looks like I will actually, right there is my point. This guy would go this way. But at 2, I am not actually defined. On this one, I'm defined here, but not here. And so I will just continue this until I get to 5. All right, and that is the piecewise defined function for number 14.